This lesson is about complex numbers, and I'm going, excuse me, to start with defining what a complex number is and hopefully explain lots of things about complex numbers that seems to be difficult, but yet it's an easy concept to understand. Definition: a complex number is any number that can be put in the form a plus bi, where a and b are real numbers and I is the imaginary unit that we're going to be talking about here in a second. A plus bi, this form is called the standard form of a complex number. Now, I is defined to be the square root of -1. And when we define I to be the square root of -1, you see we can simplify something like the square root of -16, because the square root of -16 could be thought of as the square root of 16 times the square root of -1. The square root of 16 is a 4. Square root of -1 is I. So now we can simplify the square root of -16 to be 4i. Similarly with square root of -25, that's 5i, and so on. So now we can simplify a square root with a negative number under, because we know the imaginary unit I replaces the square root of -1. Now you may think, why do we create I to be the imaginary unit, and how is that applied in real life? So if we look at a number in the standard form that's a complex number, say 2 plus 3i. Well, 2 plus 3i is the standard form of a complex number. If you want to look at graphing this number on the real and imaginary axis, think this is the real axis, this is the imaginary axis. And then the number 2, so there is 1, there is 2, it's going to be on the real axis, and the 3i, so the imaginary axis is the one that includes I. So if you go, there's 1, there's 2, there's 3. So that would represent 3i. So if you go 2 plus 3i is actually this vector. So this is the number 2 plus 3i. So 2 plus 3i represents a directed magnitude. It's a magnitude, and the magnitude is represented by the length. Its directed is represented by the angle. So if we have -1 minus 2i, that's in the standard form. So you go, where's -1? There's -1 minus 2i, there's -1i, there's -2i. So -1 minus 2i would be this vector that has this length, which represents the force, if you will, and it has a specific angle away from wherever you want to measure it. So it's a direction and a magnitude. So you can think of a complex number being a directed force, or a direction and a magnitude. And you could see the applications of those vectors in physics. In fact, the compass was made on the basis of complex numbers. So even complex numbers or imaginary numbers, the imaginary numbers that they include I, they're used in real life applications. So they're not actually imaginary applications, they're real life applications. So to help you understand the big picture here, if we think of complex numbers being this big set of numbers, then the subset of that would be the set of real numbers. So real numbers, anything on the number line. Any number on the number line is right there. And you know real numbers is divided to rational, or classified as rational and irrational. And then outside the real numbers is numbers with I, like 2i, 7 plus 3i. Anything that has I is out there, I to the power 3, and so on. So that we used to know only real numbers, but now we know a bigger set that includes real numbers as a subset which is called the complex numbers. Okay, so I'm going to go to operations with complex numbers. How do we add, subtract, multiply, and divide complex numbers? And how we simplify powers of I. I probably should start with simplifying powers of I. So let's do that. So let's look at powers of I. Okay, so we have I, then we have I squared, I cubed, I to the power 4, I to the power 5, I to the power 6. And let's jump to I to the 23, I to the 35, I to the 48, I to the 102. Okay, so we know I is the imaginary unit, so we're going to leave it there. I squared is going to be -1 because, see, I is the square root of -1. So I squared is the square root of -1 times the square root of -1 from your study of radicals. That's going to be what's under the radical, which is -1. So I probably should go to help you. I'm going to go back here. I say I squared is square root of -1 all squared. And you know when you square a number, you get what's under the radical. So that's going to give you a -1. So maybe this makes it simpler. So I squared is -1. So I squared is a real number. Okay. So let's go to I cubed. I cubed, I know I can write it as I squared times I. And the I squared is -1, so it's -1 times I, and that's -I. I to the 4, I can think of it as I squared to the power 2. And I squared is -1, so I have -1 to the power 2. And when I square -1, I get a 1. So that's another real number. See, I squared is a real number. I to the 4 is a real number. Okay. I to the 5. Well, I to the 5, I can say it's I squared to the power 2 times I. Because, see, when you raise a power to a power, you multiply, and then you have one I left. So that gives you I to the 4 times I. But think that I squared is a -1. When you square it, you're going to get a 1, right? So that becomes 1 times I, which is I. So that's imaginary. So I use the basic unit as I squared is -1. This is what I need to use to simplify powers of I. And I know in some books they use I to the 4, but I really think I squared is easier, and it saves you some steps on the long run for some expressions. I to the power 6, how can I break it down to I squared to what? Well, I squared to what power? What do I multiply 2 by to get 6? A 3. So I have I squared to the power 3, but think the I squared is -1. When you raise -1 to an odd power, you multiply the negative number by itself 3 times, an odd number of times, so you get -1. So that's also real. So how can we use I to the power 2 to simplify any power of I? So I to the 23, I use I squared as my base. And then what do I multiply it by? What power I have to have here to get 23 or less? Well, it looks like if I have 11, then 2 times 11 is 22, but I need one more I to make it 23. And think I squared is -1 to an odd power, and -1 to an odd power is going to be a -1. Multiply it by I, that's -I. Now let's look at I to the 35. So take I squared times what? That makes it 35 or less. 17. 17 times 2 is 34, so I have an I left. So I squared, replace it with -1. Notice -1 to an odd power multiplied by I. -1 to an odd power is a -1 times I, which is also -I. let's see, I to the 48 is I squared to the power 24. And that's negative 1 to the power 24. When you raise negative 1 to an even power, it's going to give you a 1. So this is a real number. Let's do 102. So we go I squared. The 102 is going to be what? 51, a power of 51. So that's negative 1 to the power 51. And that would be, you're raising negative 1 to an odd power. That's going to be a negative 1. So answers to raising powers of I will look like plus or minus 1, and plus or minus I. Any answer to raising a power of I is going to be one of those 4 possible answers. Again, using I squared as the base is going to help you simplify powers of I. I think I'm going to stop right here and finish about complex numbers next time. So I'll see you next time.